All right, we are immediately back, and we're jumping into a second example problem. This one I would like to recommend that you try yourself. So I'm going to read it off. I'll give a brief pause so you can pause the video if you want to try it yourself, and then we're going to come back together. Now this one's definitely more complicated than the last one because we're actually going to have count them, three separate legs of our trip we're going to have to deal with, instead of just our kind of two we've got going on here. So an airplane trip involves three legs. First, it goes due east 620 kilometers, then southeast at a 45-degree angle for 440 kilometers, and finally 550 kilometers at 53 degrees south of west. Determine the total displacement. So at the very least, go ahead and try to start making your picture. If you want to work this out alone, go ahead and do that. You can pause the video right now. And if you're back, we are ready to begin working out the problem. So again, having a picture is going to be a really important thing. Since this one's going to have kind of a lot going on, I'm going to make sure that I draw a big, or at least a bigger diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I made it even, so we're just going to pick a point and we're going to stick with it. We're going to go right there. Okay. So the airplane trip has three legs. First, it's going to go... I'm going to have to switch to a different color. Going to go due east. Now remember, north, east, south, west. So it's going to start going, I'm going to put it under the line slightly, just so we can get an idea here. So it's going to go due east. Then it's going to go southeast. And then it's going to go southwest. So there's our three components. And we're going to split each one of them apart from each other. So that way we can determine information and the components of all of these pieces, and then we can eventually add them together. So how I'm going to set this up, and this is how I recommend you set up a lot of these problems. This is a pretty tricky one for me to kind of have you do on your own. We're going to do an X column, and we're going to do a Y column. And we're going to basically list all of the information about each one in each of those two separate columns. So first, we're going to start with our first piece of our one. Let me see if I have a better color. We'll use blue for our first one. So for X, actually we'll stick with the baseline being purple. So first component is just horizontal. Our second component is going to be at a downward angle. I'm going to separate these from each other. Our second component is going to be at a downward angle. And our last component is also going to be at a downward angle, just kind of a different downward angle. So let's go ahead and label our kind of values here. So this one is southeast at a 45-degree angle. So we don't actually need to know the sides for that one. We can just go ahead and say I've got an X component. I've got a Y component. And the angle here between these is 45. And I know that's kind of small, but I've got a blue pen I used here, and then I'm using an orange pen here to represent the Y, and the angle in here is 45. Now for this one, it's 550 kilometers, 53 degrees south of west. So my west line would be over here. It's also X, so I'm going to use my lighter blue this time. And I'm going to use my green for the last one. And since it is south of west, this is where our angle is going to be. And our theta in the last one is going to be 53 degrees. And we also know all of our values for each one of these. Remember, we're going to be using If I go back to my black pen here, just in case you still need to reference it, I've got my right triangle, I've got my theta, I've got this, I've got my opposite, I've got my adjacent, I've got my hypotenuse, and we've got SOHCAHTOA. And so we're going to be using the same basic ideas for each one of these. Now, the first question is definitely the easiest of all the ones on here. As far as y components, there are none. There is no y component on this one. We're going to make our going to the right is going to be positive. So in this case, it's just going to be 620 kilometers. That's it. That's our first x component. We don't need to do any more work. We've got it. It's 620 kilometers to the right, so it's going to be positive. For our next component here, we want to split it into an x and a y. So to get my my x component, it's the first one. I'm going to switch to my blue color. We know the hypotenuse. The hypotenuse up here is 440. We want to find the adjacent. Adjacent is going to be CAH. We're going to use CAH cosine theta equals adjacent over hypotenuse. And we're going to rearrange that. We want to get adjacent. Adjacent equals hypotenuse times cosine theta. Let me see if I can zoom in to make this a little bit easier on you guys. This camera isn't as smooth to zoom in. Actually, wait, this one's on an arm. I can actually. Yeah, that's much better. It's out of focus, so let me fix that real quick. Properties. We're gonna configure, and we're gonna focus. Ooh, yeah, much better. Okay, sorry I didn't figure this out sooner, because, man, this is way better for you guys to be able to see it. So, scooting this over so we can see the picture again a little bit better. We're now dealing with this downward angle here. And since we want to know this piece right here, we know the hypotenuse. The hypotenuse was given to us back up here in the problem. And we want our adjacent piece. So we're just going to do cosine theta equals adjacent over hypotenuse. Multiply hypotenuse to the other side. So we'll get adjacent equals, our hypotenuse in the above question is 440 kilometers. And then we're going to multiply that by cosine of 45. Now, you could plug this in and solve for it right now, but because I have boxed myself into a corner by not giving me enough space, because I'm a big dumb sometimes, I am not going to plug and solve this in. I'm going to plug this all in one go at the very, very bottom of it. Okay, since I've got the camera in this position, we're going to also figure out the x component of this one right here. So in this case, I have the hypotenuse. I also want the adjacent. We're still going to use CAH cosine theta equals adjacent over hypotenuse. But very important this time. This case was moving to the right. It was going to the right. And we called that positive. This one's going to the left. So we actually have to call this value negative. It's going to be a negative value. So we're going to actually give this as a negative number that we're going to be plugging in for right here. So if and technically, I'm not going to explain it. That'll confuse you. So I won't actually mention that. So we're going to go ahead and make sure that whatever we solve for here we know that it's a negative number. We're going to multiply hypotenuse to the other side. So adjacent equals hypotenuse times cosine theta. Plug that in. Hypotenuse in this case is 550 times cosine of 53. So that's going to be our x component for that leg of the trip. And just make sure that we know when we plug it in, it's going to be a negative number. So all of this together will be a negative number. Okay, going over to the y side, I'm going to scoot this a little bit so we can see a little bit better. Switching to my orange, same basic approach here. Now we want the opposite and we have the hypotenuse, so we're going to need to use SOH, S-O-H, so that's sine theta equals opposite over hypotenuse. We're going to multiply to get opposite by itself. Opposite equals hypotenuse times sine theta. I gave myself more room over on this one, though, so we can actually go ahead and put it over here instead of cramming it down at the bottom. So if we put that in over here, scoot it, we will get 440 times sine 45. Same as before, I'm going to be plugging it in over there, but remember, this is getting to be a bit of a pain in the butt. Remember that this arrow is going downwards, so because it's going downwards, this is also going to be a negative value. We have to make sure we know that it's a negative value. Okay, going back to our last piece, this one was in green. Same exact approach. We're looking at this picture right here. We're going down. We want to know the opposite piece. We know the hypotenuse. So if we know the opposite, or if we know the hypotenuse and we want the opposite, we're going to need to use SOH, S-O-H, or sine theta equals opposite over hypotenuse. I will also point out while we're here that this is getting incredibly repetitive. So some of you probably would feel like this would be a waste of time. And you would be right. You don't actually have to show this much work in this level of detail on every single question. You could actually just plug in basically this piece right here. And you could have shown me that you knew that this is the formula we're using, and then just this piece and get your final answer. So now hypotenuse is 550 times sine of, I don't know why I decided to superscript that 3, of 53. Okay, I'm going to zoom out. And by zoom out, I mean just lift up the arm on this camera a little bit. And then we're going to scooch it towards the middle. So now, if we want to actually know each of our pieces, each of the pieces of information that we've got here, we're going to need to add them together. So I've got 620 kilometers. That's from my very, very top piece. Plus, my next piece is 440 times cosine 45. And then plus negative 550 times cosine 53. And then over here, I have 0 from my first component, from the first piece that's moving, plus negative 440 times sine 45. You can tell the video is going on too long. We lost the light. Plus this one's also down, so negative 550 times sine 53. Okay, let me get the light back on, and let me also get it in focus. I guess zooming in messed up my focus a little bit. And we're going to get the focus fixed so it's a little bit easier to actually tell what's going on. There we go. Okay, so now I'm going to plug all of this stuff into my calculator, and you can actually plug it in all in one go. So we're going to go ahead and do 620 You probably don't need to put that in parentheses, but I want to get in the habit of it. 440 times cosine 45, close parenthesis, because the cosine is in its own parenthesis, plus negative 550 times cosine 53, close parenthesis, close parenthesis. So I get for my x component 600.128721, and then for my y component, I've got 0, which you obviously don't need to do, plus negative 440 times sine 45, double close parenthesis, plus negative 550 times sine 53. And I got negative 750.3765142. Okay, to catch up, because there's a lot that was just happening in this problem, we had a 3-step process, and because we couldn't just do the tail to tip method of just, we can kind of logically figure it out, we had to resolve these into its components. We basically took each of these lines and gave them their own problem, and you would have probably done this in much more space and not made it nearly as cramped as mine was. Scoot this back so we can see more of the page like a professional. So the first one was just to the right. There's only a 620 to the right x component, and then there was no y component. But then for the other two, we had to actually turn them into right triangles and figure out what was their x piece and what was their y piece for each one of them. Because the down and the left are both negative, these guys had to have negative values, and then up and to the right were positive, so this one had a positive value. And then we took all of the pieces that we got from each column in the x and the y, added them together, making sure we remembered our negatives and our positives to get two values. And then this is technically not the total displacement. This is just the components of the displacement. We actually want to know what would this line, I don't think I have a color I haven't used, unfortunately. Let's see if I have anything. Ooh, lime green, that'll work. So we actually want to know what this green line, this line would be. That's what we're trying to solve for. And so in order to do that, we're actually going to need to use both of these numbers to make a right triangle. And now this is obviously not to scale, so don't freak out that these numbers don't look like they're matched. But we now need to use these numbers as though we're going over 600 and down 750. So I'm going to go up here to the top right-hand corner. That's where I've got space. So our triangle here is going to go down 750 and is going to go across 600-ish. We're going to use the full numbers for this. And so to find our hypotenuse, we're just going to use Pythagorean theorem. So we're going to do a squared. So we're going to use square root of negative 750 squared plus 600 squared. And that will give us our actual final displacement. Like I said, I'm going to use the full numbers. So I'm going to take and I'm going to try to get it in the light so we can see it a little bit better. We're going to do square root parentheses 600.12871 squared, close parenthesis, plus negative 750.3765142 squared, close parenthesis. We're going to hit enter. Oh, well, it's squaring that number, so that's weird that it doesn't. Did I do my parentheses incorrectly? No. Okay, well, we know that when you square this negative number, it's actually going to give you an answer that's positive. So it's weird that the calculator doesn't register that that's going to happen. So we can just go ahead and plug it in. We get 960.84. So our total displacement is 900, and if we go to 3 sig figs, 961 meters. Now, technically, if it asked for the actual vector, you would probably need to find the you would want to find the degrees as well to describe it, because just giving meters doesn't do good enough for that. But thankfully we have tan theta equals opposite over adjacent. So we can actually do that our theta equals inverse tangent. So we're going to do tan to the -1 opposite over adjacent, which, just to show you what that looks like really quick, inverse tangent is just the number that's above tangent if you do second. So we're going to do second tangent, and then we're going to do our angle. I'm going to describe it from up here. I'm going to describe it from right there. So opposite is going to be 600, and adjacent is going to be 750. We're simplifying it for this one just to show you kind of how it's going to work. So I would say that our angle is going to be 38.659 degrees. So what your answer would actually look like, the full answer, I ran out of room. I was a little bit overzealous with how much space I thought I was going to need. Let me get a paper I can just write on the back of really quick. There we go, that'll work. So our actual answer, the way we would actually describe our answer is that the total displacement is 961 meters at, and then we're going to take this number right here, go to 3 sig figs, at 38.7 degrees. And because I chose this to be my number, this would be going to the east of the south line. So this would be east of south, or E of S. And that, my dear students, is how you resolve them into their components and define the total displacement. Yes, that was a very long and very tedious process, but if you actually look at what we just did 4 trig functions and then added some stuff together and then did 2 more trig functions. That's literally all it was. That's the reason this class requires trig. It's not because we're going to be doing super advanced stuff beyond trig. It's because you're just going to be using it a whole bunch. So hopefully that makes sense. If you have any questions, let me know. Otherwise, this is Mr. Diamond signing off. I'm going to go eat some lunch. Have a great rest of your day, everybody.